Hi, and welcome to section 5.2 extension, graph and proportional relationships. And yet we're going to visit yet another way to determine whether or not two ratios form a proportional relationship. So here we have a table of time compared to height. Time is in seconds and height is in meters. And if you look, you'll see that it's 3 to 2, 6 to 4, 9 to 6, 12 to 18. And you can also hear my children bickering in the background. Welcome to doing videos at home. So anyway, if we simplify all of these, you'll see that they actually do simplify down to 3 to 2. So we know already that they probably are a proportional relationship. But if we graph these on a graph, you'll notice that it forms a straight line and it goes through 0. And that is another way to tell whether or not two ratios are in a proportional relationship. So let's try graphing some on our own. So let's start with this one over here, where x is 2 and y is 6. We'll see how this works with my pen. So here's the first point. Second point is 4, 8. Where's 4? There it is. 4, 8. And the third point is 6 and 10. Now if I draw a straight line through all of those points, and don't laugh at my straight line, it probably isn't that straight, but it's close enough. You'll notice that it is no way, shape, or form anywhere near 0. It is a straight line, but it doesn't pass through the point 0, 0, which is the origin. So no, that is not a proportional relationship. If we look at this proportion table, we can go, let's see here, 1, 2, right there, 2, 4, and 3, 6. And if we do draw a straight line through these, you'll notice that it really does go through 0. My line isn't so straight. So yes, this is a proportional relationship. So 1 and 2 ask you to go off and go see whether or not they're in a proportional relationship. So pause the video. You can kind of tell on these whether or not they are. Pause the video and come back and let's see if they are. Hi, welcome back. I am actually going to change my pen color and I'm going to graph them on here to see. So let's see here. X is 1 and Y is 3. X is 2, Y is 4, 3 and 5, and 4 and 6. And if I draw my line, oops, that would be up there, but this is way too far away from 0, so no, that is not a proportional relationship. All right, let's look at this one. Now don't freak out because there's decimals in this. We can say y is 1, and we can go up to half, which should be about halfway between 0 and 1. 3 is 1.5, so that's right there. 5 is 2.5, that's about right there. And 7 is 3.5, about right there. And if I draw a line, you will notice that it does go through 0. So that is a proportional relationship. Okay, let's switch to page 2. So interpreting a graph of a proportional relationship. If this graph shows that the distance traveled by the Mars rover Curiosity is proportional to the time traveled, interpret each plotted point in the graph. Well, if we look at this, 0, 0 really does mean something. It means that the Curiosity went nowhere at the very beginning. So time is 0 and it went nowhere. Not a really great surprise. If I look at 1.5, or 1 and 1.5, it means that the rover went 1.5 inches, because distance is in inches, in 1 second. So the unit rate is 1.5 inches per second. This dot here means that in 3 seconds, the rover went 4.5 inches. So from a graph of a proportional relationship, you can actually tell what each of the little points means, and it means something specific for the situation in which you're talking. Don't forget that this is the x-axis and that's the y-axis. You need to be able to read what the axis is to be able to determine what the points are. And remember, typically, time is always the x-axis. So thanks for watching.